Great. Well, I just wanted to, I want to start by just thanking Judith and Shannon and Summit for inviting me back here. It's always a thrill to come back, and I really actually appreciate this particular event a lot. I know that a lot of us go to a lot of these like tech shows, sometimes locally or AU and just tech events all over, and they can be hit or miss. In my opinion, a lot of times you'll see a lot of presentations that are obviously built with like Google image searches of like robots and circuit boards and crap that doesn't necessarily really pertain to what we do. But both times I've been here, I found the presentations relevant, a good mix between truly visionary and really practical, and like how do we, as contractors, as at-risk contractors, how do we really execute work? How are these technologies really going to help our people? I found that to be a theme. So between Alon's presentation, really kind of out there and really trying to kick us in the ass and get us to think about, where are the real threats to our industry? Where are the real threats, again, to us as at-risk contractors? And then, again, some of the practical stuff. So thank you again, and I really appreciate being here. So quick, maybe not. There you go. Okay, so just a super short introduction to the Hill Group. So we are primarily mechanical contractors, so pipe fitters, plumbers, sheet metal, and fire protection is our core construction business. We have a service business, Hill Mechanical Services, or HMS. They are, again, in the mechanical service space, plumbing service, and fire protection service. We also, between the time I was here last and now, acquired a small controls contractor, so we're starting to play in that space a little bit. That's a little bit different. But if you look at our core construction, it's again the mechanical fire protection. We're at a little north of 200 million, and then when you add in the energy services, the service and controls, and some of the other supplemental businesses, it puts us a little north of 300 million all-in revenue, serving the greater Chicago market. We're a union, and in the way it works in the States typically is, especially for the union contractors, it's not as easy to travel. So we are primarily supported, again, just in that greater Chicago market. It's a little bit north of 10 million people in that market. So it's a fairly decent size. Definitely big enough to support a roughly $300 million mechanical with competition. So here's how here's what I thought about doing today. So I thought that I'd just kind of take you through our business. So take the next half hour or so, and I think that's what I'd want to see if I was here. I want to see how are you guys performing work. What's happening in Australia that might be a little bit different. I know the last time I was here, I took a whole bunch of ideas back. So this time, what I wanted to do is just kind of walk you through how do we execute work, kind of a day in the life of Hill and the technologies and process that we use to really try to give us a competitive advantage. I broke our business up into forecasting, procuring, pre-con, building, closeout, and analytics. And I'm not going to talk about all of those because it'd be a bit much, and I don't have super cool shit to say about some of them. But I do, I want to walk through procuring, so that's estimating. Pre-con, so that's our modeling and our spooling, and how do we take it from an accepted bid or tender, right, through through the modeling, through all the through everything up to the prefabrication and construction. So that's what I'm calling build. So we'll go through a couple of our build processes and technologies, and then just touch on analytics at the end. That's something that I think is a little bit different from from what we talked about a few years ago when I was here. And it was interesting. The first thing I did when I thought about how to present and what I think you guys would find interesting was I looked at what I did in 15, and I'm like, well, obviously you can't just dust this thing off. I thought about it, but you can't just dust this thing off, right? And I am proud of some of the things we've done since then as well. So I wanted to, definitely, I'm here to share. Like I said, I took back a lot from when I was here in 15. So I'm here to share. I'm here to be transparent. I'm here to show you guys, again, how we execute. But there is a little bit of overlap. And the reason why is because some of these things I really just need to keep hammering to the industry, to the vendors, to the software companies, that we need some of these tools. So let's just start with a couple of estimating tools. So we use DesignLine. First of all, we're a fabrication shop, right? We've been a fabrication shop since about 2003. So that's the fabrication software, the fabrication suite of softwares, primarily on the ITM format. So, but DesignLine, on-screen DesignLine estimating is important to us. And I continue to, wherever I go, I continue to talk about this because it's a really powerful tool. Look, at-risk mechanicals at some point have to quantify how they're gonna price a job. And it doesn't matter if it's an IFOA or an IPD, right? The integrated forms of agreement we've got in the States. I'm not sure if you have that here, but you certainly have IPD as a concept, right? However we're gonna execute work, even if it's like super progressive, these like, space contracts where everybody's like, gets around the campfire every night, that's awesome. And those are really cool contractual ways of completing work. But, primarily we're bidding work. Even if, and I would say probably by dollar amount, I bet by dollar amount, over half of our revenue, right, over half of that 210 or 220 or 230 of core construction is executed in some form of negotiation, right? That's just kind of how that's how a lot of modern work gets executed, right? But you still got to price it at some point, which means you still got to quantify systems. Whether you're the engineer and it's design build, great, or somebody else is the engineer and you're trying to kind of price up some of the stuff. So that's what a design line looks like for us, right? So that's our takeoff. Here's a kind of an animation, right? So like this is the SMEP software. And so what you're doing is you're using real quick keystrokes to like trace out these systems. And again, it doesn't matter if you're drawing these systems from scratch, or in this particular case, you're drawing on top of a what we would call a bid document, right, or a contract document. But again, you're trying to quantify this stuff. It's faster than any other type of takeoff I'm aware of. When you know how to do it, when you have core competency, and you have the systems dialed in. That's what our takeoffs look like. That's a bid takeoff. That's not a model. It's not coordinated. There's shit crashing into stuff all over the place. I get it. But you're counting elbows. You're getting changes of elevation. That's going to get your elbow over and your elbow under, right? You need those parts and pieces, right, for labor, right? So that's and that's almost every time we do a takeoff, that's what it ends up looking like. It helps our engineers and our PMs visualize what's been done. It allows us to have different people participating in the takeoff process, and the review is pretty quick and pretty snappy. And then here's the key. So from that model, we drive directly to data. Now, I realize you can't see those lines. I'll blow it up in just a second, but that represents a normal schedule of values for a job at bid time, right, at tender. Each line here is a system. So you've got your low pressure, return supply, medium pressure, return supply, exhaust for level 1. And then for each level, you've got all the different systems involved, right? When you're building up an estimate for a job, this is what you want. And then obviously you need the schedule of values where you to get the job going forward to understand where you are in your billing cycle and it just makes sense of how things are going. And then if you're ever going to round trip and compare back, you need this level of breakdown. We all do this in some form or another. What I'm saying is that you can go from that design line to the schedule of values. Once you've got it all dialed in, it really is just a couple of clicks. And so we use MCA for laboring pipe, valves, and fittings, and SMACNA for our fabrication labor and our installation labor on the sheet metal side. And one thing that we've really dialed in over the years is that we used to labor based on you just count your PVF and you get your labor factor, right? And then you might count hangers, you might not, but then you've got all sorts of other stuff that's involved, right? You've got all the ancillaries and the weld rod on the pipe side. On the sheet metal side, because we're a sheet metal manufacturer, we're doing somewhere between 1.5 and 3 million pounds of sheet metal a year we push out of our shop. And so you've got all the clips and screws and nuts and gaskets, and how do you count all that? Well, typically it was done via a percentage. So we'd say, okay, well, if I got 10,000 pounds, call that 5,000 pounds worth of metal, and I'll say 20% of that for all that crap, and then I've got, so maybe that's another, $2,000 or whatever, and that's kind of how you built it. So, but what we're doing with this technology over time is driving those percentages out of our business, so that I know based on this. I'm not sure if this is going to work, but I know based on that, it's not, but I know based on this takeoff, right, based on all those parts and pieces, were I to pump that job out of my shop, I know that it would take that many man days for shop time, that many man days for field time, that many man days for hanger, that much material cost based on current material values, right? That much ancillary cost, so that's all your clips, it's counting clips and screws and gaskets and all that other shit. That's your total cost, that's your SMACNA at 1.0, and then this is some Hill stuff you're not going to care about. But those values are real values based on creating those fittings to move air from those locations to those other locations. So driving percentages out of the shop. This is just to quickly hit on the pipe side. So here's a pipe takeoff. Again, that's a takeoff. Sorry. Again, that's a takeoff. That's not a BIM for I could fab that, but I wouldn't because look, obviously I've got to do something there, but you're not going to get to that level of takeoff when you're just trying to estimate a job, right? So this is, so on the PVF side, I just, again, just in an effort to be, transparent, we've found that, a lot of these softwares were created so that you could you have your part numbers, right? And then you can, you use like a pricing service and then, find out what the multiplier against each commodity category is with your pipe house, right? And we just found that didn't work out real well. So what we did is we went to our main suppliers, and basically what you're looking at right now is just a custom EDI. We went to our suppliers and we said, look, here's all your part numbers, right? We've cross-referenced this with all of our part numbers, right? So we've got this cross-reference file between Hill codes and vendor 1, vendor 2, vendor 3, so on, right? And so we've got this cross-reference file. We're talking about PVF and mechanical. There's 16, 18, 20, 25,000 of these things that we use. It's a lot, right? But how many times have you opened up an Excel file with more than 25,000 lines, right? It happens all the time. It's not impossible, especially when buying pipe and installing pipe is what we do, right? This is our core competency. So we should be able to price this stuff on the fly based on today's values, based on what I can buy it for. So we've negotiated with the vendors. We get a file once a week that's got, it's really just 2 columns. It's got, here's all my part numbers, and here's what I will sell it to you, Hill Mechanical, at your volume based on our relationship this week. And so we load these every week, and and so when we say, hey, give me, when I say here, give me bid multipliers, what I'm really saying is, take the raw number from the vendor based on, because these are very aggressive. I mean, we're a fairly large mechanical, right? So we have some leverage. We have some ability to negotiate fairly decent pricing, right? And there's some incentives in there and some other stuff. But the point is, if I take their raw number, right, there's no meat on that number typically, right? That's the number that we're gonna buy it for. So, you just have some radio buttons in here to say, hey, give me a bid number, give me a change order number, which for the mechanicals in the room, you know what that means. For the GCs, it's just like the bid number. So we can price up in real time what we're actually going to pay for those items. So that's kind of what I had on the estimating side. They're old systems, but they're super important and super valuable to what we do, and we need something that does pretty similar to what that is. I get asked a lot, okay, but it's the world is Revit, right? Who said yesterday software is eating the world? I know that's a popular quote, and I actually appreciate that on so many levels, but sometimes it seems like Revit's eating the world. And so it's like, why don't, if that PDF document really was made from a Revit file, why don't you just use that? And look, the greater Chicago market is an architectural hub, right? We talked a little bit about SOM yesterday. They're based in Chicago. A lot of the big architects are based in Chicago, which means a lot of the consulting engineers that service that strong architectural community are based in Chicago. We have a strong MEP consulting engineer ecosystem in our city, right? And this is like, you can't just this is a MEP consultant's design model. This is our conversion of it. So you're just taking that, converting the RFAs to ITMs, and then obviously all of our ITMs carry all of that rich labor and pricing information. So you can't do it. This is the best one we've found. And if you look at the conversion as a raw file, there's still holes in places where fittings didn't make sense, and just there's a couple of problems. One, you really have to have a tight, really well-built system of families if you're using, generic Revit to create these models, which is what most consultants in the States do. Maybe it's different here, and more power to you if you have better experience with this. But I'm just saying, in the States, these consulting engineers, these models they're bad. They're really bad. Now, in their defense, they're not paid to model. They're not paid to coordinate. They never were. And if you look at what they've been asked to do over the last 10 to 15 years, it's all the same shit they've always been asked to do, except faster, right? And with more changes, So we're saying to that community, look, you're going to do all your engineering, you're going to do all your scheduling, you're going to do it quicker. But now, instead of just getting a new sheet of paper every time you want to draw, a system, you're going to do it in a coordinated 3D with means and methods that actually make sense and could be built. Come on, that's not realistic at all. So we're just, so we try, but we find that, again, because if we mess this takeoff off, what's going to end up happening is we're going to be paying the owner, at the end of the day, a chunk of money for the privilege of building for them, right? That's what at-risk means to us, right? So we can't, I'm not saying we never mess up, we definitely do, but we can't do it on purpose, right? I mean, we can't just, say, let's convert the model and move on and hope, right? That's not like a good business model. So it's tough. It's tough to do that. We find that to be a rough experience. So pre-con, again, so we've got the job, right? Hey, we we took it off right, we priced it right, we negotiated well, we know what our cost basis is, we feel comfortable, and we're gonna go build it. Probably one of the larger differences between the last, 4 or 5 years for us is that while we're still in the fabrication software, we are 100% Revit now. So all of our modeling, we've got between 25 and 40 full-time BIM designers. They're all working in Revit all day, every day. We're taking advantage of a lot of the things. I got a couple of shots about that, or some of the ways we're taking advantage of being in the Revit environment as opposed to a CAD environment. But you can kind of, just see that we're modeling in Revit, but with our fabrication system. So this is one thing that Autodesk has done for us, we feel, as an industry that's been of enormous value, right? So we've built these systems, these particular systems. We've built these parts and pieces over many, many years. Again, with all of that rich costing and labor and data, and on the sheet metal side, it all goes to all these different machines. On the pipe side, you can send out PCF files for cutting on your plasma torches, right? It's integrated with all this automation and all this shop machinery. We'll touch on that in a little bit. But the bottom line is we're using all of that richness and all of that effort, but within the Revit environment, and kind of getting some value there as well. That wasn't really so that's and you know what? We're using RFA content when it makes sense, and we're using ITM content when it makes sense. And again, we're using custom workflows. I'll talk about when it makes sense. We're using raw Revit capability when it makes sense. And it really is. It's definitely a value add for our business to be in this kind of hybrid, Revit-based hybrid ITM RFA world. We find that to be the most value for us right now. So the next set of slides, we call it the ribbon. So we've, just the API and the fact that Revit is more of a database and less of just lines and circles and spheres and meshes. It's more of a database, obviously. It's got a lot more capability in terms of what you can do. So if what we found is if you start to program some stuff within the Revit API, using the Revit API, what you can do is make, this is our hill fabrication ribbon right there. And there's like 1, 2, 3 different hill ribbons, just all different things that we integrate with our business. So my point here was not to show you, oh, hey, you guys should make this program, because this is our hanger fabrication. This is like our hanger fabrication wizard, right? It wasn't to say, hey, Australia, you should do hangers like this, right? Everybody's business is going to be different. The reason why I just wanted to walk through a couple of slides, though, is just show you, in case any of you don't know, just how much you can integrate Revit with your business workflow. So for us, we fabricate every hanger in our shop, cut to length, tagged, color-coded, ready to go out to an insert, right? That's how we do 90-95% of our supports and our hangers, right? So that it's obviously pretty critical that they get fabricated right, and so you've got a series of steps that you need to take people through. And again, the point isn't on these screens. The point isn't to understand what this is doing. The point is to understand that this is walking a designer through a process from doing something with the support rod, doing something with the support bearer, doing something with the naming system that means a lot to our field, right? To our on-site installers. We integrate with Trimble, obviously, for locating all of the inserts. Even if we're drilling shells, we're still using Trimble, right? So you've got to integrate the process with that. And then we're 100% based on MAJs at the end of the day. The MAJ file is the basic format of the fabrication software. And so everything for us ends up being an MAJ in some format or another. And I will walk through that. But again, the point here is that we've built a process using Revit and the API to integrate our BIM team with our fabrication team and with our installation team, right? Those guys are all communicating on a common platform. I'll go quickly through some of these. Again, you've got checks. If you want to say how many fittings, in this particular case, that's wheels saying, hey, 7% of the fittings on this job are fittings we really, really don't like to manufacture, right? And we're looking at this data every time, fabrication issues. Again, the point here is not that this is what you want to do. The point is that there is an opportunity to really integrate, custom workflows with your business. For us, I was going to touch on spooling real quick. We use Spool Gen, and I'll talk about that in just a second, but we use Spool Gen for PVF spooling, and then we have our own thing for duct spooling. I was going to kind of show both. So for those of you who aren't aware, Spool Gen is this, it's this ancient software that takes a PCF format. So PCF is a pipe component format. It's open. It's a text file. It's a text file that tells you, hey, this spool starts there. It's got a piece of pipe this long, a T, another spool piece, and then an elbow, and maybe a valve. It's just got the definition of what the spool is. So here we're using a little bit of custom stuff to create the spools, and then you're doing something with the valve handle here, and then you're going to push these out to the PCF file. That's what we're doing right here. You might have some cost code information, some other stuff that you'll pump in here. But at the end of the day, you've created a PCF file. So in this particular case, that was just 3. Normally, you'd have hundreds, dozens, hundreds in a specific floor or view. You'd have hundreds of these. You'd define them all, and then what the Spool Gen software does is it creates all the sheets that look like this. So this is a not to scale pipe isometric. This is very common in the industrial world in the United States. When some of the not auto spooling, but spooling augmentation stuff came around with the fabrication software and some of the other BIM offering softwares, you had that true to scale 3D look, which is how our sheet metal is going to look here in just a second. But for whatever reason, our shop, our fitters really like this format. There's not a lot of ambiguity to it. They can really see what's going on. To me, this is cryptic and hard to read, but our guys they really like this. And so, again, the point here is to use this technology to integrate a workflow that makes sense for your business and how you execute work. Our guys wanted to see this. We can make thousands of these sheets in the space of 5, 10, 15, 20 minutes, right? It's all based on just computer work, because Spool Gen makes the sheet from the PCF. So you define it, and then that goes to a PCF, and then Spool Gen consumes that PCF file and then outputs, again, thousands of these spool sheets, and then we can fab from there. On the sheet metal side, they don't want to see that. So this is you're creating duct assembly. So in effect, on the sheet metal side, so on the spool side, we use the spool field of the ITM to define it and help us to create that PCF file that then is consumed by Spool Gen, makes the spool sheets. The PCF file also makes an output that will be read by my 5-axis pipe cutter. So if it's a manifold, if it's got OLEDs, right, I don't have to key that in at that station in the shop. On the sheet metal side, we're using Revit assemblies. So there's a little bit of an algorithm work we've done to kind of make that a little bit faster. But once you define that, then shoot, I'm going to run that again. Sorry. So so you go in here, you click. You don't have to click everything, just like on the pipe side where you can click your beginning and end, and it'll get everything in there. You click your beginning and end, and then you go here, you define your assemblies. And then, so in this particular case, we got 3 assemblies. Again, here we're giving it an area, maybe a cost code. Always a CAM file, right? So for us, MAJ, CAM file. Everything we do, you kick out a CAM file, right? Even if it's not a shop process per se, everything gets digitized via the MAJ format. So in this particular case, we created 3, and then what happens is now those are in your Revit, in your views as a sheet. And the little algorithm we made, it does dimension and then create the multiple different views, and then obviously your little BOM. So it's like a sheet metal spooling, we call it sheet metal assemblies. So yeah, not to belabor the point, these are statuses. So again, if you've got these interconnected systems, you can push information from from a fab process back, right? So so we're able to push our fabrication status based on what we've done in our shops back into our model in color code by whether they were fabricated or not. Tools we did not have 4 years ago when we were not in Revit. We made the decision to transition to be a Revit shop about 2.5 years ago now. And it took a good year to really get up to speed, to get that initial set of trainings done, and then probably a full 2 years to transition a department of, again, fluctuate somewhere between 25 and 40 BIM people, BIM designers, to transition them from fabrication in CAD to fabrication in Revit. Door to door was about 2 years. We do a lot of scanning now. We have a scanner. Let's see. We bought a scanner in the last 6 months. That's what it looks like. It's that BLK 360. We were not in this business for a long time. In our market, and I don't know if this is unique to Chicago. I have to ask some of my peeps on the West Coast. But I know in our market, a lot of the GCs, right, they all offer this as a profit center. So it'd be a tough move for me to kind of come in there and be like, I'm doing that too, right? When all of the GCs, our main customers are all, they offer that as a service. So that wasn't really an option for us. But when the price point of these little guys came down, this was, I think, $20K. 25 with some training and some accessories, right? So you're looking at $25,000, but you're able to do some really cool scanning. And the way we this thing, I'll tell you guys, this scanner is never quiet. It's doing something every day. It's one of those things where it's like, we're not going to scan. We'll just use the GC scan. It's not always, they obviously have a different incentive than we do. They need comprehensive scans of the spaces that the electricals and the layout and drywall, everybody can use, right? And it's got to be comprehensive, and so they might not be super interested in the details above this little area where we've got a gate valve with the big ass stem, and so but again, it's supposed to be used by everybody. It's supposed to be more comprehensive, right? So. It's just one of those things where we're not going to scan. And then we looked at some of the prices on these scanners and how fast they are now and how they register themselves so quickly, right? Like you can shoot a scan and then shoot a scan. Remember, I don't know if you guys remember the balls you'd have to stick on the wall, or there was a lot of registering all your different scans. So they stitched together into one coherent point cloud was a pain in the ass. And now you literally don't have to do shit. You just literally scan, and then you scan over there, and you open up your thing, and it's all registered, and it's all stitched together. The algorithms are amazing, and they're fast. And so, like I said, it's just one of those. It's one of those tools where I was like, we don't need that. We don't need that. We don't need that. Everybody agreed. Field, PMs, executives, BIM, we don't need that. And then we bought it, and then like 3 weeks later, you have people storming into the office being like, I can't work. I don't have the scanner. There's no way I can work today. And it's like, well, how the hell did you this has been like 7 days since we had this thing, right? That's what happened with robotic laser layout too. It was like so fast. Like I brought this laser out there. It's like what, like 2008, 9. You get the tripod out there, and we're on a deck. It hasn't been poured yet, and my fitter foreman comes up and he's like, "What the fuck is that? How is that going to work?" And we're trying. And I'm like, it takes me 15 minutes to locate a point. I'm like, okay, but do you see? He's like, this is just, And I swear to God, within a month, we had our foreman coming in, and they were like, "There's this. We need more. We need more Trimbles. We can't work." And it was like, this technology didn't exist 6 months ago, and it just injected itself into our process so quickly because it makes so much sense. It's so much nicer to grab a piece of tech if it's smooth and if it makes sense and if it talks to the guys, but to say, hey, here I am, and it says walk 17 feet to your left, right, to locate your insert, right, as opposed to having a 100-foot steel tape and finding control lines. And when the tech works, man, it really works. Of course, the flip side is when it doesn't, boy, does it not work. So build. So now we want to build, right? So we've identified our. We've got the job, we've done the pre-con, we're happy with the model, everything's spooled and the assemblies are ready to go, and so now we've got to build it. I showed a lot of pictures and images of our work product in 2015 when I was here. This time here's what I was gonna do. I got mechanical pipe, you could see all the prefabricated hangers, racking systems, plumbing. We do a lot of plumbing fab, and I'll talk about that in just a second. Sheet metal, almost everything is assembled. We really don't ship out a single piece of sheet metal. We really try not to. In fact, we make it hard based on those processes that we've injected into our business and our workflow. We've made it really hard to order a piece of sheet metal. You could do it with remote entry, but if you're working with a BIM process, it's actually much easier to order assemblies than it is to order individual pieces of ductwork. And then mechanical pipe, and then now this is one thing that we've done in the last couple of years. We converted one of our spaces to a clean room. We're doing orbital welded stainless steel pharmaceutical piping. For the pharmaceutical industry at this point, it's a little bit of it's a different, it's an area that we're trying to gain some momentum in right now. But what I really wanted to do is just, this is like a 90-second drone fly through of our shop. So this will give you guys a sense of what we're working with. So that's our plumbing shop right there. We've got one floor. It's a little over 100,000 square feet. I'm so sorry. I'm good with Celsius. I'm good with kilometers. I'm not good with square meters and square feet. So, but 100,000 square, a little over 100,000 square feet. That's we've got 2 pipe shops in there. That's our main pipe fabrication shop. This is our clean room, orbital stainless steel, pharmaceutical grade, semiconductor grade. Clean room pipe shop. This is our sheet metal shop. So 2 tables, both with decoilers. Obviously a coil line with the decoiler. Your lock forming space. I'm going to go through a couple of the other machines here in a second, so you could see what we've got in terms of automations and machinery. But and then we've got a modular construction space here, so you can see, and I'm going to touch on modular here in a second, but so you've got the 100,000 square foot pipe, plumbing, sheet metal shop, and then you've got a building dedicated to really what I would call fitting out like major pieces of equipment we might bring in If you saw that helicopter lift on the video in the beginning, you get stuff like that. You got to fly stuff up. Chicago is a vertical market. There's a lot of similarities between Chicago and Melbourne. With the river and a lot of vertical, and so you've got to rig a lot of that stuff. So we'll use that high bay for rigging and for modular. So that kind of gives you a sense of our space, of our fab space, and where we're building. Again, on the shop machinery, just to go through a couple of things that we've changed over the last few years. So we used to have two plasma tables, two 20-foot plasma tables, both with decoilers. We bought this laser table not that long ago. Laser tables, if you could look, I'm cutting out our logo here, right? What's that? No. I know exactly what you're talking about, though. That's funny, Summit. Summit's funny. You guys know that? Summit is definitely funny. Anyway, so here, but I wanted to show this because this is what's cool about it. Look, if you make metal, right, and I know we don't all, but some of you guys do. Some of you guys are, or you're, and I know there's some really sophisticated sheet metal manufacturers, specifically in Australia, right? But this is like the scanner, where it was like something like this. These like high-end laser tables, they were really expensive, and they really come down. The world is a smaller, more connected place that creates a lot of problems, right? Economically, politically, but there's some benefits there too. And one of those benefits is that this kind of stuff was a little out of our reach maybe 10 years ago. And within the last, like I said, we bought this table in the last year. It's not out of our reach anymore. And there's some benefit. I mean, the edges are just, it's so smooth. It's really allowing us to be a better sheet metal manufacturer. We have a water jet, a 20-foot water jet specifically for cutting liner. I know these water jets are amazing, 40,000 PSI. If you put some particulates in the stream, you can cut half-inch, quarter-inch, half-inch plate metal like butter, right, with water. But we use it specifically for liner. And again, all the patterns come from the BIM, right? All the nesting comes through cam duct. It's all pretty smooth. We put a plasma torch on our coil line so that, so using dynamic holes in the fab system, when those pieces are coming off, the holes are being cut, on all of the pieces of straight coming off the coil line. That's kind of so rectangular, round, all those tap holes are coming through. This is our plasma, this is our pipe cutting plasma. This is an old machine, but it works and it absorbs the PCF file. It's not a PCF file, it's a different format. But the point is, basically I can take PCF and then put it into that machine and it'll cut out my OLEDs and my holes. If it understands the difference between a square cut and that, your 37.5 bevel. It's all kind of embedded into that file format. We use Tiger stops. This is a little bit new. I know that, if you're not familiar, I mean, really this machine, when you think about it, it's like, how do we not have this before? But it really just moves and takes away the need for a tape measure to measure a length of pipe. We've got a pretty slick setup here where you've got one Tiger stop that on one side measures out the rods, and on the other side you reverse the coordinates and you measure out the unistrut or the angle iron or whatever you're. So typically, you've got a lot of unistrut. So you take two, you hit the button. It's automated. It's injected into our fabrication software. So you'll or our shop, our Hill Analytics shop software. So you'll put two rods down, you'll hit the button, you'll jam them home, cut them, and then hit the button, it goes to the other side, you throw a piece of unistrut down, slam that home, chop that, and you've got your, it's a pretty slick little system for fabricating hangers. Again, if you're cutting the rods to length especially, which we have been doing for a long time, that helps us to be faster. digitized shop. So again, there's your spools. This is an example of our plumbing fab. These tables are magnetic and these stands are magnetic. So you've got your tablet with your your work orders. Again, we have a suite of custom softwares, and I know there's a lot of fabs, what would you call shop augmentation software. But just, I know there's a lot of outfits out there that are in that space right now, and that's awesome. There's some are obviously, I think, a little bit better than others. Our stuff just happens to be a little bit on the more custom side and a little bit more integrated with some of our other workflows and other business. But you've got, our guys are, they're always communicating, right? These are all MAJs here on the screens. So okay, each MAJ represents a package of work that needs to get on a truck. So they're all specific work orders. I was gonna so on the modular side, I wanted to just mention a couple of things. This I just wanted to mention. This I'm really showing for Warwick and Russell. When I was here in 2015, you guys showed me some of this, and I was like, oh my God, that's amazing. So this is just my way of saying, hey, thank you. We did some of this stuff in the last four years. I saw some of this really long, really big, super aggressive racking systems here, and thank you, Australia. We took this back, and we did some of this on some of our large data center work. I showed bathroom pods. We are, for those that weren't here, we've done somewhere in the neighborhood of about $9 million worth of manufactured bathroom pods. Where for most of that work, we were not the mechanical on the job at all. We were strictly a provider of modular pods. We have now done a lot of, we've done exam rooms now. So that's basically that room as you see it right there coming out of our shop, minus the non-fixed stuff. So your chairs and your mobile cart are gonna be like the only things that we're not shipping out. So that's that same space that we were doing the pods in. And I wanted to I just wanted to pause here for a second and just talk about modular. It's not like, look, we're union. Our wages are relatively high. Now with that, we get also a relatively well-educated, safety-conscious workforce. So there's a couple of, there's two sides to that, right? So we've got a highly educated, safety-conscious workforce, but they also have relatively high wages, relative to other places in the States. It's not like we're gonna be competitive everywhere, right? Making this stuff at that scale. But for the Chicago market, and there are some super progressive customers, mainly in the higher education and healthcare space, where they go, you know what? I know I need so many of these exam rooms, right? They look at it, think about their business from their perspective. They know they've got this many millions of people in this market. They expect to have this many customers. That's this many doctor's visits. That's this many physicians. That's this much space over the course of a year, right? It's just do math from their angle, right? They come to us as the community of builders, and they say, look, I know I need X number of exam rooms, more 2 years from now or a year from now than I have right now, right? But they might not know based on tax and jurisdiction and pricing out architects, and they may not know where they're gonna be. Are they gonna be in a horizontal build, in new construction horizontal build in the suburbs of Chicago? Are they gonna be vertical downtown? They're not always 100% sure where those spaces are gonna be and what they're gonna look like, but they know that they need so many of them, right? And so they come to what we find is like, hey, well, we can start building the rooms. And sometimes we build them without a floor because they're going into an existing space. Sometimes we build them with the floor because they're going into new construction, right? So we're building the rooms and we're giving them some value in terms of scheduling, general conditions, quality, right? And again, standardization. So we're giving them some benefits there and then allowing them the flexibility to figure out where are they gonna actually be putting these rooms, right? So that's kind of a different angle on how it's working in Chicago. The other thing I just know, and I mean, this is just something that I've had conversations with a few of you guys. Look, where are the threats? That's what, those are the conversations that I so appreciate when I'm here and I'm at these, especially here where you got high quality conversations all over the place. Where are the threats? Where are and to me, people figuring out, I've said this a couple of times, people figuring out how to float stuff up the Yarra River or how to float stuff up the Chicago River and install it in my market without my labor, that seems like a threat. That seems like something we should figure out. So we are not in this space primarily to go, to go compete worldwide. I'm definitely not in the right city, county, wage structure to do that. But we feel like, if we could provide some value to our customers locally within that market ecosystem, and while we're doing that, build an ability to understand how to work in this arena. We feel like we don't have all the answers, but I definitely don't want to be completely on the outside looking in when it comes to modular and multi-trade. So that, and then I thought with analytics, there's just a couple of things we're doing. Look, so everything for us is an MHA. These are all custom software packages that we've written. Some of them are kind of extensive. Some of them are very similar to something you could buy commercially. For us, that's not the point. For us, the point is that it's all connected into a coherent analytical system, right? So each one of these is an MHA. It also represents a workflow for our shop. Right? It's talking to our ERP. It's connected to our ERP. That's the stack. That's for each one. That's the stack to each shop on the sheet metal side. You're measuring workflow. I wanted to pause here for a second. Like if you get an order in and that order represents an MHA and when you receive that order and based on using our analytics software, when they're asking for it, you can do simple pie charts like how much lead time are we getting from our people? By foreman, how much lead time are they giving us, right? What is the relative size of an order? So is an order, in this thing, this is telling you that in this case right there, I'm not asking you guys to read this, but I'll just explain. What this little graph is telling us is almost a quarter of our shop orders are less than 100 pounds. Somebody's ordered a couple of, how much, it doesn't take much to make 100 pounds worth of stuff. That doesn't seem super efficient, so we're able to track this. I know I snapped this a while ago. I know based on our people and our workflows, I know that these charts would look different because we go to our people and we communicate order size. The value of an order is important, right? Metrics is probably the most important thing that our fabrication software does, right? At its very core, what it's doing is saying, hey, I know what an MHA is, and I know what an MHA is to you, and I know what our ERP is, and I know that gives me payroll based on cost code and what we call a task code. So if you're in our sheet metal shop, the cost code's for medium pressure. Nobody gives a shit in the shop if it's medium pressure. They care, right, what they're doing. Are they on the coil line, right? Are they welding 6-inch, right? Are they tacking up 18-inch? So those core, 30 or 40 different shop activities, they know what those are. And then, so based on the fact that every pipe order, every sheet metal order, every plumbing prefab order is an MAJ that we know is in our SQL database, and we know it ties together with our ERP, we're always, always, always driving to metrics so we know what our production rates are in our shop. And then we're starting to build out some other stuff, and these are all of our spools. So we're building like some. Right now, we're in the process of finishing up a field analytics ordering system. It's kind of like a little bit of an Amazon thing where you can go in there and say, hey, here's all your spools. And you can dial them in, and then say I want these ordered, and it's just kind of like tying together again our shops, our BIM, and our field installation onto one coherent system. So that's what we're working on right now. So yeah, that is my walkthrough through our business. And listen, I thank you all for the time. Really appreciate it.